Hello guys, Benjamin here. Today we are going to discuss about empirical formula in chemistry. The empirical formula of a compound represents the simplest whole number ratio of the atoms of each element in the compound. They essentially provide a simplified version of a compound's composition. Here's a table comparing molecular formula to empirical formula. As you can see here with ethane, you got 2 carbon atoms to 6 hydrogen atoms per molecule, so if we were to simplify that, it will be CH3, and that is the empirical formula. We use empirical formulas to determine the basic ratio of elements, especially when analyzing unknown substances. Here's an example. What is the molecular formula for an unknown sample containing 40% carbon, 6.71% hydrogen, and 53.29% oxygen, with the molar mass being 180 grams per mole? Our first step is to convert from percentages to grams, so we have 40 grams of carbon, 6.71 grams of hydrogen, and 53.29 grams of oxygen. We then divide these values by their molar masses to convert to moles. With our mole values, we then divide them by the lowest of them all, which is 3.33. Finally, we have found our empirical formula with 1 carbon atom, 2 hydrogen atoms, and 1 oxygen atom. We are not finished yet though, because the molar mass of CH2O is 30.03 grams per mole. Although our ratios of elements are correct, it is still far off from our sample with a molar mass of 180. So what we do now is to divide the expected molar mass by the molar mass of the empirical formula, and that approximately equals 6. We then multiply the atoms of the empirical formula by 6. Think of it like using distributive property. The molecular formula is C6H12O6. Moving on. So in this problem, we got 27.29% sodium, 1.18% hydrogen, 14.51% carbon, and 57.02% oxygen, with the molar mass being 170. So again, here are the steps. Convert from percentages to grams. We then convert to moles. Now, we divide all by the lowest mole value, which is 1.17. And now, we get NaCHO3. However, that is only the empirical formula, so we add up all of the atoms to equal the molar mass of the empirical formula, and then divide it by the actual molar mass, which equals 2. So the actual formula of this sample is Na2C2H2O6. Alright, so this third question is actually slightly different. So what is the molecular formula of an unknown sample containing 36.84% nitrogen and 63.16% oxygen, with the molar mass being 76? So starting out like always, we convert from percentages to grams, so 36.84 grams of nitrogen and 63.16 grams of oxygen. We then convert from grams to moles, with the lowest value being 2.63. So we divide both mole values by 2.63. However, we end up with products of 1 nitrogen atom and 1.5 oxygen atoms. In this case, 1.5 is not enough to round to 2, but in order to make them both whole numbers while also preserving the ratio, we need to multiply both numbers by 2. So 1 times 2 equals 2, and 1.5 times 2 equals 3. We then solve for the molar mass of N2O3, but it matches the value mentioned in the question. This means that the empirical formula equals the molecular formula. Alright, thank you for watching this tutorial. Have a good day and good luck on empirical formulas.